Hello, my name is Colin Doyle, and I'm a Senior Systems Engineer at Juniper Networks. This is the seventh and final video in a series that demonstrates to the viewer how to install, configure, and operate a Juniper SD-WAN test environment on their own laptop or desktop computer. In my previous video, we created and deployed a client subnet to our VSRX spoke and created some basic policies to allow access to the internet and local breakout for traffic to yahoo.com. In this video, we'll configure SD-WAN policies and do a practical demonstration of link switchover. That's right, we finally get to use our link conditioning guest. This is what the entire series is building up to, and I am excited. So let's begin. Our first step, as always, is to fire up all of our virtual machines. I've done this already in the interest of time. Upper left-hand corner, I have the virtual machine we'll be using to do our path conditioning. The upper right-hand corner, I have the client that's attached behind our VSRX gateway. We'll use that to generate the traffic we'll test against, in this case YouTube. And then I have the VSRX gateway itself powered up here at the bottom. Logged into CSO, and here we can see just a transient amount of NTP and DNS traffic, so we're not actually doing any traffic generation from our client at the moment. Our first step for creating an SD-WAN profile is to go here to Configuration, then to SD-WAN, and then define an SLA. SLAs are agnostic to applications. They're actually just applied to application traffic in the SD-WAN policy itself. These profiles define a common set of switchover criteria. It can be any or all of the criteria you define. And again, they can be applied to multiple applications. These are the numbers you're looking for. I'd also note that as we get into this, what we're defining here is actually the behavior of the application. We use active and passive probes and a process called app QoE, or quality of experience. And before I move on, this traffic type profile, I talked about it in the previous video. It's underlay QoS, and generally can be ignored, but it's something you work out with your provider. Also, I'm going to show you what it looks like when you enter custom values. This is where you would go to actually define a specific value, or you can also use the slider and it'll change those values for you if you like. I'll do custom, and I'll just do this for the sake of this video here. Path preference any. And the session sampling I'll explain when we start to generate traffic, because it's a little bit more of a discussion than what we'll have time for while I'm doing the deployment here. Violation 1, sampling period 10 seconds. Let's make this 30 seconds, that's better. Okay. Like I was saying, you can apply the profile to as many applications as you like. It's just a common set of criteria. And since we use app QoE, we have passive probes that are running with application traffic on the link that traffic is currently flowing over. So we're actually shimming information in, and this is kind of where that sample rate bit comes in that you saw in the previous window. And on the other links, we're running active probes. So we're monitoring constantly the overall quality of all the links, and then we're monitoring the quality of the specific applications defined by an SLA. So when we talk about packet loss in terms of jitter and round trip time and latency in a application, we're actually monitoring the application for that, because we've all had an experience where we're connected to a network, and if we look at the link connection speed and how some of our things are behaving, everything looks okay, and then a couple of the other applications are acting like garbage, right? Just because you have a connection that, here we can even look at the Wi-Fi here that says, oh look, I'm connected at 263 mega. That does not guarantee that everything's going to work right. So we need to get a little deeper. So now that I have a profile defined, I'll go in here and I'll create my policy. I can see the breakout policy I created in a previous video and apparently forgot to name. We'll click create here, and I'll just call it YouTube, because that's what we'll be testing against, because it makes a simple test, nice visuals. We'll select the client department. Again, we could apply this to all if we wanted to. And just type in the first couple letters to YouTube and have that. And then we'll select our profile here. And click save, and then we'll deploy. All right. And deploy. And this shouldn't take long. So I think it is a really clever thing that we do with the app QoE and actually monitoring the actual health of the traffic itself. And we'll come back to that sample rate, because I'm going to let YouTube run a bit just so that we can see the traffic, we have defined default interfaces for our WAN traffic and for our breakout traffic. So everything should be pinned to WAN 0. But I'm going to show you how to check that and verify it prior to starting your test as well. So we're good here. And I'm just going to jump over here and fire this up and start a video. And one thing to remember about YouTube is that it does a very good job of trying to conserve bandwidth. So you'll usually see like a pretty big spike when you fire up a video, and then you'll see that spike drop off as it starts to, buffering algorithms kick in, all that optimization starts to take place. So we have some clever ways of sort of gaming that a bit. One would be to find a playlist of a bunch of short videos. If you're not familiar with Vines are, they're 7 to 10-second videos. Actually, I think it's 7's the cap, actually. I don't know. I was never really a Vine person. But we can go to Vine playlist, find something clean. Hey, I bet this one's clean. And we can just play that in the background. And what we'll do now is we'll wait a bit for some traffic to show up here. Remember, when we're applying these configurations, they all exist on the gateway itself. And we disaggregate the control plane and we manage and monitor it from CSO. But it's important to remember that because when you see things like link switch events or you have security policies, they're not reliant on communicating with the portal here to function properly. They're out there and they need to be, because you need to have fast switchover regardless of what your connection to the CSO portal is. And you need to be able to have security policies that don't require an OAM connection back to some controller. So when we start to kick off traffic, there is a period of time where traffic's running, but we're not going to see it here in this log. Now, when the information does show up in the log, the time information and all that, it is correct. And you can go to monitor and go to traffic logs and see this stuff a little bit more in real time. You can also log directly into the box. We don't lock you out of the SRX, although we would caution people against trying to make any changes or doing anything more than operational level commands. But something else that's pretty cool about our solution is that it's all there. It's all standards based under the hood, and you can still log into the box. You can still connect your monitoring tools to it. You can actually see the QoEs starting to kick off here. And so we're just going to give this a minute. I'll put myself on mute. We'll give it 5 minutes just so that we can see the bouncy line, and then I'll show you how we can verify that it's on the WAN 0 link. All right, that line right there is good enough for me. Now, if we were to let this run longer, what we'd end up seeing is it would kind of peak, and then it would start to slowly level out. The vines kind of keep the traffic high, but man, those engineers at YouTube, they're pretty clever. So let's turn this off. Now we can go over here, and if we want to just make sure we know what interface it's on, go to resources, the SRX spoke, WAN. There's a couple different ways to get to this page, but this is the way I get here. We'll look for top applications, and we'll see YouTube. We can click on YouTube, and in fact, we know the only traffic running here is YouTube right here. But if you get in an environment where you've got a lot of different types of traffic, you can click on the application itself, and you can see that we only actually even see WAN 0 here. If there had been traffic on WAN 1 for this application, we would see WAN 1 represented here as well. So we know it's on WAN 0, which is great because that means we know where to put our link conditioning. So let's have some fun. All right. I'm going to open up my Pi here, and I'm going to show you how this works before we actually run it for real. So from my client testing the system, which is on the right here, we know our traffic's on WAN 0 because we have a default. Now, we haven't defined any other SLAs. We know that our ping is going to go across the same path. I'm just going to start pinging Google. Now, when we installed, configured and set up and installed this virtual machine over here, I explained kind of what Bridge Utils and TC does. TC is for traffic control, and this is the first time we're actually going to use it. I know I mentioned it, but now you can see it in action. So I'm going to introduce delay into the link but not so much that it triggers a failover event. I'm just going to do like 50 milliseconds. So we'll do CDTC, and I've got a cheat sheet on how this all works, so you don't have to memorize this. In fact, you can just write exactly what I'm writing here if you want to do this just for this purpose. But I would encourage you to kind of get a little bit more familiar with the tool, because there's a lot of cool stuff you can do with it. So we'll do delay 300 milliseconds. Now I know that I can apply this to either ETH0 or ETH2. When we built our Ethernet bridge, we bridged 0 to 2 and 1 to 3. 0 and 2 are for WAN 0, and 1 and 3 are for WAN 1 on the VSRX. So watch this. Oh, that went through 300. I'm reading my instructions here. We'll just do 50 milliseconds. And if you look over at the right, you'll see the ping time jump by 50 milliseconds. So we're going to be doing that. We're going to add 300 milliseconds, and that should trigger our YouTube event. So delete dev ETH0 root. All right, and that'll remove it. And we can always verify that it's removed, because if I run the same command again, it comes back with the no file, then we know it's gone. So up arrow twice, 300 milliseconds. And before I do that, I'm going to start YouTube. And in order to make sure that this does what I want it to do, I'm going to open it a couple different times. And I'll explain why while we're waiting for the traffic statistics to come up. All right, and for this test, I don't actually really care. I just need sessions. I don't need volume. So sure, we'll just start clicking on the first things that come up here. Why not? Great. Make sure we actually have stuff playing. Eventually. Come on, you. There we are. Okay, good. All right. So we have our ping in the right here. Let's hit it with the delay. Right, we'll see that jump up. See how it went over 400. Now our SLA says 300, so that should definitely trigger the SLA. And now we'll let it run. Now this failover is going to happen fairly quickly because of the configuration that I've applied. And we're going to go back to that now, and I'll kind of explain what it is, as promised. So let's look at this here real quick. I don't want to click the edit button, it'll complain. It won't break anything, but I'll lay it out here. Actually, I will click the edit button because I know that there's a typo right here we don't need to talk about. All right, so I entered a custom one. I didn't really need to. I just wanted to show you how that works because, again, different applications, different services, you're probably going to want to have different thresholds for switchover events. I don't have a path preference, which means that I'll use any available link that's happier. We talked about app QoE a bit in earlier videos. I think I talked about it earlier in this one. This is the second time I've recorded this because I had a cat meow earlier, so I re-recorded. App QoE, or App Quality of Experience, uses probes. We do active probes on links that don't have the specific application traffic that we have an SLA defined for. Those active probes are monitoring the health of the link. And then we have passive probes for the traffic itself on the link that it's actually flowing over. And what that is, kind of like a shim that we add to the packet for the application that we then extract on the other side to monitor the performance of the actual application itself. So we're not just looking at the link, we're actually tracking the application, which I think is really clever and cool. The SLA sampling down here kind of gives a hint at how those passive probes operate. Now, normally you would never set 100% session sampling rate. That'd be akin to doing, IPFix or NetFlow for 100% of all your traffic. It's just going to be a really big hit, and you generally don't need to. Your account team, Juniper, we can help you sort of figure out the proper values for there. Or you can just keep the defaults. The violation count I set to 1, and the sampling period I dropped to 30 seconds. The cool off is just how quickly it'll switch back to a default link if you've defined one. Also bearing in mind that if that link also has terrible, if it violates the SLA, which is the importance of an active probe, we're not going to switch something to a link that will violate the current SLA. Just won't happen. So I changed these thresholds so that I could test switchover using one client with a couple different YouTube windows open. You don't want to necessarily, actually, the situation I can think of, trigger a switchover because one person who's watching, in this case YouTube, has a problem. You're really looking for kind of the holistic health of an application. So you're going to do that by sampling sessions. Presumably, if you have a mission critical application that has an SLA defined for it, it's going to be in use by a lot of different people. So you're going to have a pretty diverse set of sessions. So as you sample those at a certain percentage, you'll get a pretty good cross section of the overall health of the application. And then we have the SLA violation count and sampling periods because if somebody has a blip, you don't necessarily want to kick everybody off one link and onto another one. We want to make sure that we're having some sort of persistent issue, and that persistent issue can be defined by you however you want to define it. It could be 2 or 3 violations in the course of 60 seconds. It could be that's a bit of a tuning piece, and we have guidance that we can provide on that as well. And for the purpose of what we're doing, I know that I'm creating the violation and I want to trigger the failover immediately, right? I want it to switch links, because I'm demonstrating it. So I set these here. I would never set it like this in a production environment because this is just far too aggressive. All right, so this is already flipped. We can see that that delay is still running on that WAN 0 because we're just switching over YouTube. We're not switching over our ping. I don't expect to ever see that number drop down until I turn the delay off. So this is on WAN 0, but YouTube's on WAN 1 now. Now we just need to see if I can show you. There it is. So you can look at the time up here, 10:12, and I just don't have a monitor large enough to make this work. There it is. Link switch time, 10. All right, so you can see that happen immediately, and this is where things get kind of neat. I can go into the application SLA performance and go into that VSRX spoke. Wait for the information to come in, and I'll probably just change this to previous hour so the graphs are a little bit better spread out. All right, does not look like the data is populated to here first. Normally you'll see the switch event first. Oh, wait, here we go. Yep, there it is. And you can see this is where the link, I hit the threshold. See that little red line there? And jitter, it's funny, jitter usually gets triggered too because it's such a vast difference that for that moment, within that sample size of 30, it suddenly goes from 100 to 400. It completely skews the value. But it was the RTT that actually triggered the failover. You can see that here. I can click on YouTube and actually click on the name there. It'll give me a little scatter plot of the performance and some additional information on the application and switchover events and what have you. And we can change this to RTT because that was what we were doing. And you can see right here where it flipped over to WAN 1, which is pretty cool. Now, if you go to the site itself, and there's also widgets for this, I'm just not going to get into it. I can go to WAN, I can go right to where we went before. Come on. Right to where we went before. I had an email come in just at that moment. Probably slowed this page load down just a bit. Oh, geez. All right, here we go. You can see right here, WAN 0 on the top, WAN 1 on the bottom. This little 0 here is the link switch event. And it's cool because you can see it uses an arrow and it'll actually show you that it lasted, let's see, in this case, 26 seconds. And remember, our monitoring time, our sample time is 30 seconds. So it was within that sample time. And we see that it spiked to 396 milliseconds for round trip. And you can see the arrow here, and it tells you at the bottom, towards the bottom, links, source, destination. It's flipped from WAN 0 to WAN 1. And I'm not going to wait for it to happen, but I will tell you this. Since we did define default links, I'm going to kill this delay. And after a period of time, the active probes will indicate that the default link, which is WAN 0, is in a healthy state again, and the YouTube traffic will actually flip back to WAN 0. And that is it. That is a basic test. And that is also the end of the series. If you started with me on the first video where I kind of gave the overview and you've come all this way, I want to thank you so much. My intention here was for this to be informative and also, technical enough that it could be useful, but not so technical that it couldn't be used by, anybody with access to CSO and a hypervisor they could load this up in, and just some basic understanding of how the product works. As always, if you have any questions, put them in the comments below. Feel free to reach out to me directly. I will probably do additional videos that deal with specific features of CSO, but that wraps the series. And again, thank you so much for joining me. A lot of fun doing this. Take care. Have a great rest.